Review of ratio, rate, and proportion. Let's review some definitions of what a ratio is compared to a rate compared to a proportion. Again, this is a review from information that you would have learned in grade 9, but it might have been a while, so it's important for us to make sure that we're all on the same page. So a ratio is a comparison between two or more values. It's important that we note that ratios contain the same units for both properties, and they contain whole numbers. So we want to avoid decimal numbers in a ratio. So some examples of ratios, they can be written as a regular ratio, which is 1 to 2, so we're using that colon symbol, or they can be used expressed as words, so 1 to 2, or they can be expressed as a fraction, so 1 over 2. A rate is still a comparison, but this time the two quantities that it compares can be different units. Some examples of rates could be kilometers per hour, maybe the amount of money you make per hour. It could even be the how much it costs per liter of gas. And a proportion is where we set two ratios equal to each other. And it's a set of two equal ratios. So this is where we look at those ratios or fractions when we think about equivalent fractions. Those would be the same thing for proportions. So we might compare 1 over 2 to be the same as 4 over 8. And oftentimes we use proportions when we're looking for an unknown. So let's go over some examples. So the first thing we want to do is reduce the following ratios to lowest terms. And we do that the same as we did when we looked at reducing fractions to lowest terms. We're looking for the greatest common factor. So we're looking for the largest number that will divide evenly into both the first and the second term in our ratio. So in our case, we can divide both of these by 4. So 12 divided by 4 is 3, and 16 divided by 4 is 4. So the ratio in lowest terms is 3 to 4. Then we take a look at part B. We have 35 to 28. The largest number that divides evenly into both of those numbers is 7. So 35 divided by 7 is 5, and 28 divided by 7 is 4. And the last one, 150 to 900, again, we want to look for the largest number that divides evenly into both of these numbers. If you need to do it in steps, that's perfectly fine. If you can find your greatest common factor right away, that's even better. So the largest number that divides evenly into both of these is 150. So 150 divided by 150 is 1. And 900 divided by 150 is 6. The next thing that we're going to review is how to find the unit rate. So the unit rate is a rate where the second value is always 1. So we're comparing it to 1 of something, 1 hour, one person, and so on. So if we want to find the unit rate of the following situation, so Tom drives 288 kilometers in 4 hours, what we want to figure out is how many kilometers he can drive in 1 hour. And in order to do that, we take the number of kilometers, so 288, and we divide that by the number of hours that he's driven for. And we can use our calculator to do that calculation, and we come up with an answer of 72. So the unit rate is 72 kilometers per hour. So for every hour that he's driven, he has driven 72 kilometers or traveled 72 kilometers. The next example, Sue makes $110.50 for working 13 hours. So we want to know how much she made per hour. So we're taking the amount of money that she's made, so 110.50, and we're dividing it by the number of hours that she worked, which is 13, and that gives us an answer of 8.50. We always have to remember that when we're dealing with money, we keep 2 decimal places. So if it only gives you 8.5 in your calculator, you have to know that when you write your final solution, it's $8.50. So add that extra 0 at the end, and it's $8.50 per hour. And the last example, a dog walker walked 20 dogs and earned $55. So we want to know how much they earn per dog. So we're going to take the total amount that they earned, 55, and divide it by the number of dogs that they walked, which is 20. And that gives us an answer of 2.75. So that means this person made $2.75 per dog. The next example we're going to look at is where we're solving for those proportions. So this is where we're solving for an unknown. So we're not only using what we know about proportions and equivalent fractions, but we're also thinking about what are some strategies that I can use from my algebra skills. So sometimes you're going to be able to identify what the missing number is by doing some mental math. So using our multiplication table facts, that will be very helpful for us. We know that 10, if I divide 10 by 2, I get 5. So if I'm going in this direction, so from my first fraction to my second fraction, or my first ratio to my second ratio, I'm dividing. So if I'm going in the opposite direction, I'm going to do the opposite of division, which is multiplication. So 4 times 2 is what x is going to be, and so x will equal 8. So that's a quick and easy way to solve for your unknown value if you can determine a nice whole number that the numbers can either divide by or multiply by. Sometimes though, it's not that easy. So there's nothing we can multiply 6 by in order for us to get 9. That makes a whole number. So we're going to have to do this by using our algebra skills. So we know that whenever what we're trying to do is we're trying to isolate for the variable. So we're trying to isolate for w. We want to get w all by itself. And in order to do that, we have to move whatever numbers are on the same side as the w. And we have to look at what the operation is that's happening between the w and the number. So right now, whenever we have a fraction, that means division. So w divided by 6. So the opposite of division is multiplication. So we're going to multiply both sides of my equation by 6, because whatever I do to one side of my equation, I have to do to the other side of the equation in order to keep it balanced for every step. So what that looks like is we have 6, and then we have w over 6. So I'm multiplying this fraction by 6, and that is equal to, again, I'm going to multiply my second fraction by 6, which is 12 over 9. I know that if I take a number and I have it at the top of a fraction and the bottom of the fraction. If they're both the same, they cancel each other out because 6 divided by 6 is 1. So, and 1 times any number is always just that number itself. So I have W remaining on the left-hand side, which is what I want. And then I can do this in a couple of different ways. Probably the easiest thing to think about is to multiply the number by the numerator. So 6 times 12 gives you 72. And then you're going to take that value and divide by your denominator. So 72 divided by 9 is 8. And so that's a way that we can calculate for that missing value in our proportion. So using what we know about our algebra skills to isolate for that variable. Another way that you might remember or might have been taught is doing cross multiplication, which isn't always the best strategy in mathematically, but it is a strategy that works. So what cross multiplication means is that we can take the numbers, so the numerator from the one proportion with the denominator of the other, and we're going to multiply those together. And then we're going to multiply the numerator and the denominator of the other ones together. So we are cross multiplying those answers or those values together to get an equation. So what this looks like is we have 13.5 times D. So remember, if there's no symbol in between those, that means multiplication. And that's equal to 54 times 1.5. And so what we're going to do now is we're going to calculate what 54 times 1.5 is, and that gives us 81. And then the last thing that we want to do is we want to isolate for that D again. We want to get the D all by itself. And so we do that by doing the opposite of multiplication, which is division. So we're dividing both sides by 13.5. So we have 13.5D divided by 13.5, and that's equal to 81 over 13.5. Some people skip this step in that solution, and that's fine as well. So we know that 13.5 divided by 13.5 is 1. So those two cancel each other out, and we're left with D. And 81 divided by 13.5 gives us 6. And so those are 3 different strategies that you can use to solve for a proportion. If you have any questions about this topic, please reach out to me by email or sign up for a virtual help session, and I will see you in the next lesson.